good day everyone. My name is Mr. Hosea Yakubu. You're welcome to another session of Mathematics for the African Child. I want to discuss one another interesting subtopic of differential calculus called quotient rule, derivation of the quotient rule formula, and I will apply it, so that you learn and also apply. I will use the simplest methods so far. All right. Suppose we are given three functions, y, u, and v, such that the function y is equal to u over v. We can actually find the derivative of this function. By finding the derivative, it means we are going to find the dy over dx of the same function. So how do we do that? Let's see. Now, we now say, okay, let y being equal to u over v be equation 1. Then increment in this will affect this. That will now give you y plus changing y will be equal to u plus changing u over v plus changing v. Then as at this point, since you cannot simplify further, you call this one equation 2. Then you subtract equation 1 from equation 2. If you do that, see what you have. Now, this will now give you y plus changing y like this minus y. Being equal to then this, being equal to u plus changing u over v plus changing v minus u over v. Oh, let me remove this. We'll still get there. All right? Yes, as easy as it is. So from this point, you can simplify the right and the left hand side. If we are simplifying the right hand side, this will clear this because they are a number and it's additive inverse. So on the right hand side, we are left with changing y being equal to. Now this other side, the only way you can simplify it is by finding the LCM of this. So the LCM will now be v into v plus changing v, like this. Then the whole of this into this, you'll be left with v. Then v times this, that will now give us v into u plus changing u, like this. Then this v into the whole of this v will go, the v will go. What are you left with? We're left with changing v plus changing v times, now we now have minus. You have u into v plus changing v, like this. So we can easily simplify it. Simplify the numerator. Now that will give us changing y will be equal to, let's expand this, we now have uv, then plus v changing u minus uv minus u changing v, all over v plus changing v. So if we are working it, please, you check out the numerator very well. You discover that this is a number and it's additive inverse. So it will go, we'll end up having changing y will be equal to v changing u minus u changing v all over. Then we'll now expand this. That will give us v squared plus v changing v. Then, if we have this, what do we need to do next? We'll now say, okay, let's divide all through by changing x. Now that will give us changing y over changing x being equal to v changing u, we have v changing u minus u changing v all over v squared plus v changing v divide by changing x. Divide by changing x. So, simple arithmetic, you know, this is the same thing as over 1. Simple arithmetic, from simple arithmetic, will end up having changing y over changing x will be equal to, now we have v changing u minus u changing v all over v squared plus v changing v times 1 over changing x. So now, we'll now say changing x into changing x will be 1. Changing x into this, see what you have, you end up having changing y over changing x will be equal to v changing u minus u changing v all over changing x, then over v squared plus v changing v, while the other side is 1. So if you want to simplify this further, what will you have? You end up having changing y over changing x will be equal to, now that will give us v changing u over changing x minus u changing v over changing x all over v squared plus v changing v. Then as at this point, we take the limit as changing v tends to 0. Now we now see as changing v tends to 0. We end up having changing y over changing x will be equal to v changing u over changing x minus u changing v over changing x all over v squared. So this is our quotient rule. So I think the next thing is we'll try to apply 1 or 2 questions on that, and we'll be very okay. All right, now we want to apply simple examples, you know, using quotient rule. So look at this. Suppose we are given these questions. How do you find the derivative of these functions? You now say, okay, solution. That means solution for 1, solution for question 1. Now I will now say let y be equal to 1 plus x squared over 1 minus x squared, and I also say such that u is equal to 1 plus x squared and v is equal to 1 minus x squared. Very simple. So based on that, I can now say, okay, let me find the derivative of the function u with respect to x. That will now give us du over dx. This will be equal to 2x. Then the derivative of the function v with respect to x will now be equal to minus 2x. Then we now say, okay, from dy over dx being equal to v du over dx minus u dv over dx all over v squared. What we need to do now is just to substitute into the derived formula. Now look at the way I will substitute it. I will now have my dy over dx will be equal to, so I will have a parenthesis. What is my v? My v is 1 minus x squared. Then my du over dx, is times 2x. So I will close it, have my minus, then what is my u? My u is 1 plus x squared, then times dv over dx, which is times minus 2x, all over v squared. Look at this, 1 minus 1 minus x squared all squared. As easy as it is. So we've actually gotten our derivative. If you want to simplify further, it's very simple. We'll end up having something like dy over dx being equal to, so we now have 2x minus 2x cubed, and group like this, we'll have minus, and we'll multiply this, that will give us minus 2x minus 2x cubed. Then that all over 1 minus x squared all squared. So we can still expand the numerator. If we do that, see what we are getting. If we do that, see what we are getting. Now we will end up having dy over dx will be equal to, now we end up having 2x minus 2x cubed, then plus 2x plus 2x cubed, all over 1 minus x squared all squared. Look at it very well, all squared. So in cases like this, you will notice that this is the additive inverse of this. So that will go. This will strike out this. We'll end up having dy over dx will be equal to 4x all over 1 minus x squared all squared. This is the derivative of our function. Okay, in the second example, that's for 2, we now say let y be equal to, let's say let y be equal to 3 plus 2x minus x squared all over the root of 1 plus x. Then we also say, now say okay, and u be equal to 3 plus 2x minus x squared, then v be equal to the root of 1 plus x. So, looking at this, what do we do next? Now say, okay, we can find the derivative of the function u with respect to x. That will now give us du over dx. So, our result will be 2 minus 2x. Then for this, we know that this implies that v is equal to 1 plus x raised to power 1 over 2. So if we are going to find the derivative of v, the function v with respect to x, that will now give us dv over dx will be equal to 1 over 2 into 1 plus x to the power of minus 1 over 2, then the derivative of this times 1. So when we do that, dv over dx will be equal to 1 over 2 now times 1 over root 1 plus x. That we can simplify it further. Dv will be equal to, dv over dx will be equal to 1 over 2 roots 1 plus x. So in cases like this, we can easily simplify it to the quotient rule formula, which states that dy over dx is equal to v du over dx minus u dv over dx all over v squared. So if we are substituting it, see what happens. That will now give us dy over dx will be equal to, what is our v? Our v is root 1 plus x, then times times du over dx. What is our du over dx? Our du over dx is 2 minus 2x. Then minus our u what is our u? Our u is 3 plus 2x minus x squared times our dv over dx times 1 over, and we have 1 over 2 root 1 plus x. So we can simplify further. If we do that, we end up having dy over dx will be equal to, that will now give us 2 minus 2x root 1 plus x. Okay, here, all over, what is our v squared? Our v squared is root 1 plus x all squared. So now say minus, that will now give us 3 plus 2x minus x squared all over 2 root 1 plus x all over 1 plus x all squared. You can simplify further. You can simplify further if you so wish, but that's our derivative. Alright, that's all about this. If you like my videos, please you click on subscribe and tap the notification button.